Okay, this is section 4.3. We deal with log laws. These things are important to solve equations. And you really need to know these things. So the first one we're going to talk about, if we've got log some base A of A times B, capital A and capital B can be variables, they can be numbers, they can be algebraic expressions, they can be just about anything, will equal to log base A of whatever A is plus log base A of whatever B is. Now oftentimes you're actually going to use this to go back this way, because these laws go both ways. So second one, log base A of A over B. So you notice this is a product, this is a quotient. It's going to be log base A of whatever A is minus log base A of whatever B is. Okay, so there's two of them. And again, more than likely, with this one, instead of going this way, you're going to be going this way with it. Number three, log base A of whatever A is to some power C. And C does not have to be a number. C can be anything. It can be a variable or an algebraic expression. But it's whatever A is, and it's raised to the C power. Is going to equal to C times log base A of whatever A was. And this is one of the most commonly used one. Number four, and this one's called change of base. And this is probably the most important one. So log base A of something, which might be x, is going to equal to natural log of x over natural log of A. And what makes this thing important are two things, and this is the one you're going to be dealing with a lot when we start solving exponential equations, is that these you can plug into a calculator, the other ones you can't. But anytime we start dealing with log base A, I'm going to expect you to convert it out to natural log. You can use log base 10, which is log rather than natural log, but I would prefer, and almost everyone else would prefer, that you deal with natural logs. And in calculus and on above, everything we deal with is going to be dealing with natural logs and not with log base 10. Okay, and again, number 3 and 4 are going to be the two most important ones for you to deal with. Let's work some examples of these things. I want to keep these up. So the first example then, I've got log base 3 of 27. So what we need to do here, of the square root of 27, is rewrite this as a rational exponent. So it's log base 3 of 27 to the 1/2. With this being how you rewrite square roots. It's really important you guys get this piece of information down. So now we can come back in. I've got something like this. And if you look, it looks like number 3. I've got log. There's my little a. There's capital A. And this is C. So I plug it in back in here. So I'm going to have 1/2 log base 3 of 27. That equals x, by the way. We're trying to solve for x. So I can rewrite this thing. I'm going to have 1/2. That thing stays out front. And I'm going to rewrite this as, here's my base. So it's going to be 3 to some power is 27. Or excuse me, we're not doing this, we're evaluating. We want you to evaluate, which means simplify and solve it out. Okay, so there we go, 3 to some power. Now I know x has to equal 3 because 3 cubed is 27. So what I'm going to have then is, and then I have to divide by 2, so it's going to be 3/2. Okay, let's work another one. They're asking you to simplify these. Log base 4 of 192 minus log base 4 of 3. All right, now you notice this guy looks like this side of this one, where this is little a. You notice they both have to be the same. This is capital A, and this is capital B. So what I'm going to do is I'm going to take this and go in this direction. So now it becomes log base 4 of A, which is 192, over 3. And you can simplify 192 over 3. So it's going to be log base 4 of 64. And I write this, what I need to know is 4 to what power is going to equal to 64, and the answer is, it's 3. And that's the solution to it. Okay, let's take a look at one more here. 2 more. Okay, so your directions here are to expand. These were to evaluate, but the ones I just worked where you actually had to solve them. This one to is expand, and they give you log base 2 of AB squared. And we want to expand that. All right, well, I've got AB here. Now I notice B is squared, but let's deal with that a little bit later. So let's take this and we're going to go in this direction. So I'm going to have log base 2 of A plus log base 2 of B squared. Okay, and this is this. So now I'm going to end up with log base 2 of A plus, and since that's an exponent, you bring it outside the log, 2 log base 2 of B. And that's the expanded version of that. Okay. Just deal with one more here. On this one, you're asked to evaluate or solve it. And they give you log base 2 of 5. Okay, well, your calculator doesn't have a log base 2. And so in order to do this one, we have to resort to the change of base formula. So there's my x, and there's my a. So this is going to equal to natural log of 5 divided by natural log of 2. And when you plug this into your calculator, it's approximately 2.32. And this is how you will be using log